All right. Good morning. Welcome to week 6 of our 16-week semester. This week, we'll just cover a little bit about traditional BI and what happened um, as data sources became more varied and coming at you at higher speed. I do apologize. That's a typo. And then we will cover the week 6 assignments. There are none. Everybody got that? No assignments due this week. But I did want to talk a little bit about business intelligence. And I know a little bit about Microsoft Power BI, not a whole lot. I think at least one of you is a developer in Power BI. So you're in this stuff all day, every day. So yeah, the business intelligence lifecycle. Business intelligence is using data to inform key business decisions. And it's like the data analytics lifecycle, the data science lifecycle. It's like the software development lifecycle where you always start with a requirement. I mean, like we all know, you got to chart your course. I guess some of you might be fortunate enough to be doing just pure research. Just go play around with this stuff and check out this data, see what you can find out. But most of us are working towards some sort of business requirement. So, and this cycle here involves pretty much all the steps that you would take, not just designing a particular dashboard, but analyzing business requirements so that you know what it is you want to know to implement business intelligence. Because most organizations, so at least the ones I work with, have multiple support systems and data in multiple formats being stored in different temporal granularities, at different timestamps and whatnot. You get at the data differently. There's different APIs for different support systems, or having to pull data out in whatever format, JSON, CSV. So you got to design a data model of the stuff you need to know about from those systems. May not be right, may not be, may not fit together very well. So you've got to design some kind of data model. You can use databases that are schema-less. You can read data into like MongoDB and start querying without really designing a schema. But generally speaking, this is the traditional business intelligence lifecycle. Generally speaking, you will design some sort of a data mart or a data warehouse that pulls data in these different formats from these different support systems into a coherent, unified model. So you got to design that model, and then you've got to actually design the physical infrastructure, or you got to decide if you're going to be in MongoDB, or you're going to be in SQL Server or MySQL or whatever. You've got to decide if you're going to be on premise or in the cloud. There's table structure and indexes and views and whatnot that go into physically implementing this abstract data model design. And then number 4, you actually build the data warehouse. I've got a family member that does this day in, day out, running standard SQL SQL queries, as well as like stored procedures and triggers and whatnot, to move data from production This is a retail chain, to move data from production systems that happen to all be Microsoft, but the data mart is in Postgres. So there's a slight change in um, the names of data types and whatnot between when you move between relational databases. But it doesn't have to be in a relational database. It could be a combination of a relational database and a NoSQL database and maybe even a graph database, depending on what you're working on. But you've got to actually build that data warehouse, because you're, generally speaking, your business intelligence software that's doing your reporting and your dashboards and whatnot, you don't generally want to link those to a production system. Um, there's too much performance hit that could happen if somebody writes the wrong kind of query or whatever. You know what I mean? You can hang things up pretty well. But anyway, so once you've got the data warehouse, now uh, you have a central repository where you can now just, create a business intelligence project where you can, now the business intelligence project is sort of another module separate from the data warehouse. So this could be going on in parallel. But you want to decide what tool you're using. There's, check the content folder this week. There's a bunch of tools out there. Tableau and Power BI are really big, but there's Domo and Google Data Studio. There's cloud-based options out there. So you've got to decide, what tool, what roles and responsibilities, who's doing what's the project schedule, how will you measure, completion, how do you measure status, all the usual project management stuff. And then the BI objects are the actual individual visualizations and collections of visualizations and reports and whatnot that you would develop in the actual tool. That's the fun part of actually building this stuff. And then you move on to administer and maintain, where your business intelligence products become a software configuration item. So an executive or a user somewhere could actually ask for improvements that go into the same kind of requirements analysis and prioritization processes that you would see in traditional software development. Administer and maintain. You got new users coming in, you got to give them views. A lot of these, especially Microsoft, the business intelligence tools integrate so tightly with the broader environment, permissions coming from Active Directory and roles and responsibilities in SharePoint. A lot of these visualizations are shared on Microsoft 365, Teams, SharePoint, that whole Microsoft collaborative ecosystem. So somebody's got to maintain that whole environment. And then, of course, you back around. Um, the you can short circuit this kind of thing. Sometimes you might start in phase 5 if there's no change to the data warehouse. It may just be a new set of KPIs, key performance indicators, that you're working with. So anyway, yeah, it's just like anything else. There's a cycle to it. Okay, so a data warehouse. Generally speaking, over here we have the support systems, customer relationship management. So there's all your marketing, your customers, your engagement strategy is all implemented and documented in your CRM. Then ERP, enterprise resource planning. That's, generally speaking, that's what's tracking your processes as you go through the manufacturing process, kind of internally, billing, finance and accounting. There's just um, no end of that data. Supply chain can be integrated with ERP, can be a separate solution. But yeah, supply chain is how you're buying your subassemblies and materials and converting them into value. And then in the middle we have the ETL. So we got gears grinding, and like I said, that's a extract, transform, and load. That's where you pull data out of those various systems. Could be done with um, like in the Microsoft ecosystem, they've got a tool called SSIS, SQL Server Information Services, and that's a GUI, a tool that like an IDE almost, that you can create packages where it will, you know, at a time of your choosing, at a period of your choosing as a developer, it'll go and grab the data, do any sort of conversions, transformations, reductions. You might have columns that you can get rid of, or calculated columns that you need to create, or converting maybe part numbers from uh, one manufacturer's style to another. There's just any number of things you can do in that ETL process. Could be worth SS something like SSIS, or could be done with, I know companies that do all of their ETL with Python, because you can read data. There's a library called Pandas that has made Python very popular. You can pull data out of a relational database, do whatever you need to do in Python, and then write it back out to the appropriate table in your data warehouse, all within scripts, so you don't have to do that stuff manually. But the objective is to build a data warehouse that is a clean and trustworthy source of data for all your reporting needs, which are reports, visualizations, and any other subset of business intelligence. Could be, I guess, could be some machine learning, unsupervised clustering analysis and whatnot that you throw up in front of people. Although generally that's not really publicly consumable. You have to have some knowledge of data science to interpret what you're getting at. But yeah, that's business intelligence, is grabbing the appropriate data out of your enterprise, um, cleaning it up, transforming it, getting it ready for consumption by a tool that will make it usable by your management, whether that's, could be low-lying management, could be low-level management, first tier supervisors, all the way up to the board of directors. Okay, so that's traditional business intelligence, and then throwing in a wrench is big data. What changed? Well, there's you still have traditional business intelligence, a need for that, but now you've got potentially a Hadoop cluster, or a big query database that's got millions of rows that you're now integrating, you're now querying as part of your business intelligence um, uh, dashboard. So where it used to be maybe your KPIs only got down to a level of daily sales maybe, or weekly summaries, now, because of the way the news, the web, news outlets are constantly posting content in order to draw eyeballs, so you've got social media outlets and that are constantly, depending on the size of your company, constantly mentioning things that you're interested in. So all of these things, these sources of big data, can be integrated into a business intelligence platform, but they've got to be handled, like, like MongoDB can be scaled to very large amounts of data. It's got to be integrated and engineered into your business intelligence process. Um, and you've got to decide as the developer and as the organization how you're going to sort, filter, prioritize, make use of that big data within um, traditional platform. I don't think there's any silver bullet. I don't know that there's any magic. But if you want to look at, uh, uh, trending tweets and filter those tweets by, different types of products, or the name of your company, or some event that's happening that affects your company, like whatever, oil exploration, oil prices, oil spill, that stuff, that information can be integrated and and displayed full time in a corporate dashboard, an enterprise dashboard in these tools. Could be truck locations, because there's, you can do maps in in these visualization tools. So could be real time display of geographical data, any number of things, and you'll see that out there on Google Scholar. So I did want to show, for if you've never gotten curious, Power BI. It is a desktop application that you can download from Microsoft, and because it's Microsoft, it looks a lot like Excel, but it you'll find it quickly diverges. It's nice that the buttons and whatnot are similar to um, Excel, but the overall approach is different. So what I've got here is a Power BI project. Everything in Power BI is stored when you're developing, when you're designing, is stored in a Power BI project file, PBIX file. But I just wanted to point out the workflow. You can do ETL in Power BI. Over here on the fields, there's let's click on transform data. Transform data. This brings up the first stage of a Power BI project, and that's called Power Query Editor. Oh yeah, and this project is too complex. It won't let me edit. But anyway, in Power Query Editor is where you would get rid of columns you don't need, rename columns, change the data type of a column, get rid of rows, filter out rows you don't need, those sorts of things. So you do that in Power Query Editor, and then so this is your, yeah, here we go. Your tables, more or less. So this is your data source for this project, are these basically worksheets. You bring them in a CSV format, but you can do any of the sort of transformations that you would think that you do in Excel, and they can be scripted. But an advanced Power BI user would know how to work with that. But then once you've got the data here in Power BI, and again, these are all just like tables, more or less, in a relational database. Then you can go to relationships, and it takes Power BI, when you're importing your data, it will try to create a relation like you learned in relational database design. We've all had at least had that course, even if you don't work in it. It will take a stab at which fields relate to which primary keys and foreign keys are related. And it will start to enforce that. You see, if I hover over a relationship, it shows you exactly which field is relating to which field. It will use those relationships to enforce uh, um, references and kind of automate some of your visualizations. So that's the second step. You read your data in. As you're doing that, Power BI will be analyzing it for similar fields and creating a lot of these links by yourself. But if not, you just like any other design tool, you can drag and drop and create relationships within your data. But this relational view is no different. It's the same data, just presented differently that you have over here in your when you're looking at your tables. And then, of course, you've got your actual report, and this is what most people think of are these different visualizations. Each one of these is a tile that can be sized. You can change the title, just like any other visualization in Excel. You can put summary data up here in their own little tile. By default, the data is linked. So when you click on, okay, so total revenue by product, and this is a sample, by the way. This is just it's available on the web. There's lots of resources on Power BI available online. So it looks like we got in this heat table here, we've got three products: Primus, Gladius, and Sova. When you click on one, the other visualizations filter to that product, to that view or that thing. So if I click on Gladius, you'll see the other visualizations all changed to only reflect data for the Gladius product. So that's why it's so important to have the data clean in Power Query and then properly modeled in the data model view, because by default, Power BI does a lot of things automagically. So yeah, there's several of these sample products. Here's a scorecard, a single view, and there's a whole user community. I mean, Power BI is its own now, is its own, and data visualization, business intelligence developer. That it's its own discipline now. It's a whole field of study and of technology. So anyway, that's just a peek. Uh, Now I wanted to go back to my PowerPoint. Check that out. Okay, so that's business intelligence, and companies have had that going now. For they companies have been doing dashboards for 20 years and more. So we started really dealing with big data tools, in the last 10 years or so, and integrating the results of those massive data sets boiled down to their essence and the important stuff pulled out and placed into a business intelligence solution. So that's the paper you're going to write, but it's not due this week. Remember, there's nothing due in week 6. Check the syllabus for when this business intelligence paper is due. I did want to point out it's typical literature review format. So you can approach it with the two different, well, you can approach organization however it makes sense, but make sure that you are methodically covering the instructions and that your headings show what you're doing. But one thing to really point out is there are some papers out there that talk about Fortune 1000 as if it's a company. The Fortune 1000 is this, similar construct as you've heard of the Fortune 100 or the Fortune 500, for example, and that's a list of companies by, I believe it's gross revenue. And Walmart being at the top of the Fortune 500 for years running now, Fortune 1 company. But Fortune 1000 is not a company. Fortune 1000 is a list of companies. So as you're finding case studies out there about a company, look at their Fortune rating. And I'm not, if you have any question or if you find a good case study that you want to use, or a good company that has multiple articles about their big data approach, you'll find multiple things about Tesla, about Amazon, about Walmart, about Wells Fargo Bank, for example, JP Morgan Chase. There are multiple articles or articles that you can talk about in a literature review. And it makes for a good literature review to compare how different authors have conducted their studies within the same company or about the same company. So the requirements for the paper are standard and listed in iLearn. Make sure when you talk about methodologies, you are discussing each author's methodology specific to that article, not just methodology in general. Same with data analysis, same with research questions. Don't just list a bunch of research questions. You got to cite which article was seeking which primary research question. You don't have to list all the research questions if there's a bunch of them. What's the primary research question that the author or authors were seeking to resolve? Okay, so that's the paper. I've made an announcement in the classroom about an example paper and how to analyze literature. So make sure you're reading that so that we're not making the same mistakes and getting the same feedback. I'd appreciate it. So that's it for week 6. If there's any questions or concerns, please make sure and get back to me. Okay. Have a good week. Nothing due this week.